Scientific notation. Okay, here's the thing. We use scientific notation in science in order to write really big numbers smaller, and really small numbers that are big smaller. And what does that mean? Well, what it means is I can have a number like this, 0.000012, or I can have a number like this, 230000000. Okay? Two different numbers. This is really small. This is really big. But I want to write them nicely. So the key to scientific notation is to write the number as a number between 1 and 9. Actually, between 1 and 10, but we don't use the number 10. We always just go and we say, okay, right there. I'm writing the number. It's either going to be a 1 or a 2 or a 3 or a 4 point something. Up to 9. Right? Once I get past 9, you don't write a 10 point something. You just write a 1 point, 2 point, 3 point, 4 point, 5 point, 6 point, 7 point, 8 point, 9 point. So in this case, I have a 1.2, and in this case, I have a 2.3. Okay? So, right off the bat, you write the number as a number between 1 and 10, which is actually number 1 through 9. Okay? Alright. The next step is, it goes back to our exponential rules. Okay? We want to know how many places I moved it. How many places did I move it? Well, I moved this decimal point 1, 2, 3, 4, 5, 6. 6 places. Well, that means I moved it 6 places, but that would be 10 times 10 times 10 6 times. See? Because if I move it from, let's just say, 0.12, and I move it to 1.2, if I was to move it back to here, I'd have to divide it by 10, right? If I move it from here to here, I times it by 10, right? So the more points I move it, the more times I'm multiplying it by 10 in order to move it. So in this case, I'm multiplying by a factor of 10 6 times. Okay? But there's one last thing I need to know. Did I divide it to get it there? Or did I multiply it by 10 to the 6th to get it there? So when I multiply this times this, is the number going to get bigger or is the number going to get smaller? So I look at this number and say, is this number bigger than this number? No, it's smaller. And if it's smaller, that's negative. If you go from your scientific number to your main number, and the main number is smaller than the scientific number, then your exponent on your scientific number is negative. Smaller, negative. Now if you read the book's going to tell you the opposite. So sometimes I do different things in the book, and this is one of the ways. Because it's confusing the way the book has always taught students, I believe. Because they're having you do it in an opposite way, and there's no reason to teach it that way. When you can just look at it like this. When you look at the scientific number, and you look back at the original number, the scientific number is bigger. If this number is smaller, it's negative. So when we do this one, I go, well, to get there, I have to go 1, 2, 3, 4, 5, 6, 7, 8. So there's times 10 to the 8. And I look at it and I say, well, is this number bigger or smaller than this number right here? Smaller. And this one, it's
bigger.
Way bigger, right? So that makes sense. I'm going to multiply it by a number of tens. In this case, you got to think about it as being divided by, because it's negative, being divided by a number of tens. Does that make sense? So divided by a number of tens, multiplied by a number of tens. Bigger, smaller. Okay? So, that seems pretty easy, right? But it could be harder, of course. So, let's look at the other side. So that was the one problem. What's the, let's do the next problem first.
What problem is that?
That's problem number 8? No? Oh, it's problem like number 8. I made it up. Or no, it's not even like number 8. So let's do number 8.
Okay.
That's a problem just to kind of get you in. That's right. That's a problem I made up. That's a problem I made up. And it was just to do a simple problem. Now in number 8, it wants you to do a problem. So what's 8 say?
Parentheses 13 million.
13 million. So that would be 1, 2, 3, 4, 5, 6. Okay.
Parentheses 200,000.
200,000. So that would be 1, 2, 3.
No comma on the first one. Just 2, 0, 0.
Oh, 200,000.
0, 0, 0.
200,000. Right?
Yes.
Okay. Here's the thing. Right away, you can change your things to scientific notation, or you can just do the math. So there's two ways to do it. I'm going to do one over here in blue. I'm going to do the other way in black. Okay? In blue, 1.3 times 10 to the what? 1, 2, 3, 4, 5, 6. 7. So times 10 to the 7. Okay? Is this number bigger or smaller than this number? Bigger. So this stays positive. So I'm multiplying it by tens in order to get it back up to there. That makes sense? I'm multiplying it by tens to get it bigger. Okay? And then I got to move this one. 1, 2, 3, 4, 5. So times 2.0 times 10 to the 5th. So again, I'm getting it, it's becoming bigger, so it's going to stay a positive. And then when I multiply scientific numbers, all I do is I take the two numbers and I multiply them together, and I say 1.3 times 2.0, and I get, well, if I wrote that as a 3, I would get 2 times 3, 6, and 2 times 2, so I'd get 2.6. Okay? So, not a problem yet. 2.6. And then when I multiply times 10 to the 7th times 10 to the 5th, I'm getting 7 plus 5, right? Because I'm multiplying powers that have the same base. So I add the exponents. So I get 2 to the 6th times 10 to the 12th. So that's one way to do it. Here's a little easier way, because these are easy numbers. And that is 2 times 13. 26. And how many numbers? Or how many letters? Or how many zeros? 6. 1, 2, 3, 4, 5, 6. And 5. 1, 2, 3, 4, 5. And then,
Oh my god.
yeah. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 2.6 times 10 to the 12th. So two different ways of doing it, achieving the same number. Okay. When you have harder numbers, you can use your calculator to do the 1.73 times 2.84, right? And then do the math on the tens. Easy math on the tens. Or you can have your calculator try to do it. Now here's the problem. And that's why we have scientific notation. It's because these calculators can't do really big numbers. And we're talking about when you do physics and you do the speed of light. So you're talking about like 1.6 times 10 to the 28 power. Now when you talk about things that times 10 to the 28th power, you can't put that 28 zeros in your calculator. The most you can get up to, I think, is like 12 zeros, or sometimes 8 zeros, depending on your calculator. So you have lots of problems occurring, and that's why we well, it's not why, but it's another reason why we use scientific notation is because it's called scientific notation, because in physics, in chemistry, biology, but basically in physics and chemistry, you really need to know this stuff. You really have to use this stuff a lot, because you use really small numbers and you use really big numbers. Okay? Let's do the last one really quickly and then we'll be done. And what's the last problem say?
Oh. 0.00096 over 300000. Yes.
Is that right?
Yes.
So 3 zeros after the point.
Yep.
Okay. So, here you go. This one can be a little confusing, correct? So, let's just move it into scientific notation. 9.6 times 10 and 3.0 times 10, and then we have to figure out how many tens, right? So we've got 1, 2, 3, 4. So I know there's 4 there. And 1, 2, 3, 4, 5. So I know there's 5 there. Okay? Oh, but what about one of them is getting smaller, one of them's getting bigger. So what's the deal on that? Remember we said if we take the scientific number and look at this number and it's getting smaller, it makes it, what's smaller? Negative is smaller. That's why I do it that way. It makes sense, right? Negative is smaller. Okay? So if we look at this number and it's getting bigger, then this number has to be bigger, positive. Okay? So that's good. And then what? Well, we just take the numbers and divide them. So what is 9.6 divided by 3?
3.2.
We got 3.2, right? So it's 3.2. So far, so good. Times 10 to the what? Well, times 10 to the negative 4 minus 5. Because we are what? Dividing. So we are subtracting. Does that make sense? Okay. So then, what is negative 4 minus 5? Isn't that the same as negative 4 plus a negative 5? It's easier to look at that way, huh? Which means it's negative 9. So that is equal to 3.2 times 10 to the negative 9. Did we get it in 15?